presentation. Yeah, welcome everyone again. I think over the next 15-20 minutes, we will talk about our journey with deploying applications like H2O and the full stack. We deploy full stack, Hadoop, Spark, Kafka, Cassandra, all kinds of applications on containers. So we'll talk about our journey, especially in the context of an enterprise, because majority of our customers are healthcare providers or financial services. So there is a lot more to this deployment than just doing a Docker run. How many of you are familiar with Docker, just so I don't repeat? Looks like a lot of you, so that's good. So we don't have to get deep into the Docker and just stick to the challenges and stuff. All right, so everybody is like, what's new now, right? This has happened everywhere, and this is the same set of things we have to do. And anybody who follows, data science, central, or all kinds of documentation, this is a very standard set of activities that you have to do to run any data science application or machine learning application or even BI. Right? Your activities in terms of you have to collect the data, store the data, you have to cleanse the data, and do your dimensionality reduction, or you have to understand the labels for all kinds, whether it is structured supervised learning or unsupervised learning. Your activities are the same, right? So the AI has to accommodate for these things, whether or not it's the new age AI or your existing form of doing things. So what is different now? So if you look at it, it's no longer talking to your databases, right? Not just your database. There is a lot more to where the data comes from. And that's really the focus for an enterprise from our experience, is really how you accommodate for these things and then deploy on a container for a successful deployment. So if you look at data, it's no longer about just RDBMS. You have RDBMS, and then you have data lakes, streams of data that's coming in. It could be your Spark data frames, or your, along with things like where do you store the model, where do you share the model. There is a lot of collaboration that has to happen for your things to work, right? So it's important to have a proper access to the data storage. And the next is your computing frameworks. Your computing frameworks are no longer your standard BI ETL tools. It is really a best of the breed. You have a number of different, for each use case, even within an enterprise, you may have some applications or some set of libraries that are coming from standard TensorFlow, or you may have a lot of it. You've heard about a number of different libraries here in the H2O conference about what you use, what kind of capabilities or tool sets you use in the context of H2O. So even within H2O, you have things like H2O, the pure clustered H2O, you have sparkling water, you have driverless AI, and then how do you access it? What is the UI, and what are some of the analytical tools that can connect to it? And then you have developer, or the different personas, the user persona of how you access this information, right? Unless you have these things figured out and are deployed in a proper manner, there is really no scaling that is possible. There is really no sufficient usage that's possible. We have seen a lot of applications that become shelfware because there is really no methodology to actually use it in an enterprise. So what does that mean? If you think of these applications deployed on someone's laptop or in a single VM or in a big machine, you see that it has to have access to data, whether it's big data or small data. You have choice of modeling techniques, not just about the different set of algorithms, even for data pre-processing. Right? The first slide where we saw there's a lot of things that has to happen. Data pre-processing, you have different, you may need NumPy libraries, you have your scikit-learns, Keras. There is a lot of things that you need along with your advanced algorithms, right? And then for data sets, do you copy the data in, or do you access the same data for your small experimentation? There was a session that I attended before where you had to reduce the data size to actually run on a specific set of driverless AI that they were using. So how do you actually use the entire data set and use different sets of data? Even if you want to reduce, you're not repeating or copying it into your local storage. Right? So how do you make sure you can accommodate for that? GPUs, big deal now, pretty expensive. So how do you make sure you actually can use, you can no longer dedicate a single GPU or a set of GPUs to one application. That's one of the biggest challenges we hear from people is, I have this discrete set of applications and I want to use all these things, but I can't have a machine where I exclusively run H2O, exclusively run Anaconda. So how do you make sure you can actually use it when you need it and also use it in a fashion that is actually scalable, right? And so now think scale, right? That was one machine on your laptop. Now in a real enterprise on a larger data set, it is no longer about one machine or one laptop. Now you have the issue of scalability, repeatability, complexity, and making sure that you give the same data to everyone irrespective of what application they're using, especially in model building and model comparison. You're actually comparing the performance of different models. How do you make sure that you're actually comparing apples to apples? And especially things and appropriate resource utilization for things like GPUs. Then the other thing is being able to run things simultaneously, right? Traditionally we have seen when we go into companies, it's like there is your machine dedicated for one version of a software and there is a different setup dedicated to the same software but a different version. And how do you make sure that you can actually run those things in parallel and scale out of, kind of phase out of one and start using the other one. So here comes the containers, right? The standard, why do you need a container? The isolation, scalability, repeatability, the standard DevOps, everybody loves containers, but how do you actually make containers work in a real enterprise? That's the challenges we face day to day, and that's really some of the things we want to share with you guys. So at a very high level, since all of you raised your hand, it's really a OS level virtualization without the heavyweight emulation of your hardware. So it makes it very easy. I can have Docker on my laptop. I can have Docker everywhere. But then what does it mean to use that and actually run a real workload? Right? So in a nutshell, all the applications you run are in your virtual application space. Right? It doesn't make sense for you to actually have data copied over or data in those attached to it. It is really something that has to stream into your application or come into your application on demand when you need it. So how do you make it consistent? We just have a couple of layers in the middle to make sure that there is acceleration in the data path. So your containers, the applications that are running in containers don't actually feel the latency of the compute storage separation. Other than that, this is a standard deployment of any containerized application. One of the things we have taken care of is really not all applications are designed to be cloud compatible. They're not cloud ready, they're not microservices. You can't just deploy them. What do you actually do to make sure that they run in a container even if they're not built as a microservice? Right? That's the thinking, that's the adoption that's going to make it possible when you don't force an application to be cloud compatible. For H2O also to work, we've heard about the pre-processing stage, right? You need Spark for pre-processing. Where is the data coming from? You may need Kafka for the data to come in. How do you make sure there is connectivity established? Whether or not you run all those stacks in containers, you actually need appropriate connections and appropriate security established for it to work. So if you build your own, if you're building something on containers in your own, what do you take care of, right? The things like making sure that you have appropriate set of images, and how do you make those images accessible by the end users? And then if they are using things like GPU, there is a lot more than just bringing up the container. How do you surface your GPU? And how do you make sure that you're not locked down to one particular technology or one particular cloud or whether it is on-prem? How do you make sure it is seamless and you can go across? Right? And then the UIs, and for the data, it can be HDFS, it can be NFS. How do you make sure that your container already has the data that's available and ready to go? So if you look at a deployment pattern, right, if some of your containers may have to be beefy containers, say for example, driverless AI, you may have one large container and you build you do your data visualization, you do your feature selection, and then you build your model, Pojo, Mojo, whatever you do. The output, if you want to now deploy on a larger cluster to make sure that you can run on a larger data set, you should easily be able to export to something that runs on a clustered environment. For a clustered environment, you may actually need, you can work with smaller containers, maybe scaled out architecture instead of a scale up deployment. So yeah, in all these different types of architectural deployment, you have everything running in containers, reusing the same set of infrastructure probably at different times, and making sure that you give appropriate resources to enable your applications to run. Right? So however you do, whether you have Docker Hub or whether you have some kind of a Docker repository internally, and you have all the scripts, for the traditional folks, it's the your recipes, your Puppet scripts, Chef scripts, Ansible, whatever you have. And we have our own set of scripts that can deploy a clustered multi-node interdependent services. So you have some indication of where to get the information from. And then how do you make sure that your users can actually use it in such a way that they can visually understand how much of the resources are given to each one of these applications without them having to write a YAML file each time. Typically what we have seen is adoption is slower when you have to do things manually. You have to start writing your scripts, you have to start writing your JSON, then only few users who are very good at it will use it, but you won't get the scale that you're looking for, right? Easy UI based deployment, one-click deployment, there are many different tools. They approach this from different perspectives. And what we look at it is how easily can someone come and say, I want H2O cluster, I want Driverless AI version 1.5.2 or the lower version, both running simultaneously, one using GPU, one not using GPU. Most of it is one click. With our partnership with H2O, a lot of that is one click, and your customers can have these up and running. And literally here it is about, it's not only about Driverless AI, it can be your traditional Spark workloads, it can be just running on Spark with sparkling water or just regular Spark, and selecting the appropriate resources that go with this. Right, so if you look at what goes into actually running Driverless AI, you guys have seen a lot of demos at the top level, but if you go a level below, it is really about making sure that you have the NVIDIA kernel, if it's a GPU based one, and then all the CUDA libraries, and the matrix that's tested. For those who have been doing this, it's a nightmare if you go one version off to actually have things working. To make sure this is all appropriately tested and validated, and having those things come up. Once you have it up and running, it's great. You have you can analyze, you can run, you can build models, and then if you really want to run it on large data sets, you can send it to your Spark cluster and accessing either data tap that's built using our technology or just regular HDFS, and you can run it in a larger scale. Right, so it's seamlessly being able to push that workload, build it in one place, push it to the next one, and push it to the next one, or bring it back. It's seamlessly being able to do that is really what you can accomplish with containers. And a couple of other things that we have added before we wind it down is really because of compute storage separation, whether the data is in S3 or it is in other file systems or it's in NFS, how do you make sure that you have fast access to the data, right, without latency? So that's where we have some buffering mechanisms. And also, it's not just about, like we said in the beginning, it's not just about the models and that technology. It's about where do you get the data from and how do you make sure that you have access to those things to actually make it fully production ready or to get full value out of the stack. So with containers, complexity can be reduced, but the thing to keep in mind is that you have to make sure where your data sources, your security, and your multi-node deployment, and all that is in place. Otherwise, it just becomes yet another fancy technology that some people are trying. Right? And especially with things like H2O, where they have many different deployment patterns, making it through containers makes it extremely easy, and then you feed the appropriate data systems into that. I guess, I think we are just about time's up. Maybe, do we have time for questions? Or I'm going to skip the demo, I know we don't have time.